All right, chapter 7.8.2 is about using random samples that we talked about yesterday. So random, unbiased samples to describe populations. So we're going to do a bit more work with using those proportions to figure out percentages, to figure out numbers, and then to make conclusions about populations. All right, so even unbiased samples can vary in their results. If you pull 100 people on the street one day and you pull 100 people the next day who are different people, they might have slightly different opinions. So you're not going to get the same data every time. So we'll see this today that even a good unbiased sample could have slightly different results. So we're going to use measures of center. So the median, they'll call it the center of the data, and the range of the data. And I think they call this like variation. We'll see it on the next slide. Of the data. So if you see center, you find the median. And if you see range or variation, you find how much the highest and the lowest values differ from one another. So if we have multiple samples, we can use those measurements in order to make some better conclusions about our data. For example, you and 4 friends randomly sample 20 different students in your school to see how many of them prefer pop music. So you're asking 20 people, and then 4 of your friends are also asking 20 people. So you're going to have a 100-person sample, but you each are going to have 20 answers, okay? So here's how it looks. This first row is yours. And then the second row is your friends. The third row is your other friends. So like you can see how this is going. I'm just going to kind of delineate them so that we can see a bit more clearly. Okay. These are the results of the people you asked. So if we just go back to you asked 20 people and 2 of them said they like country, 13 said pop, 4 said rock, and 1 said rap. So like those are your 20s. But then if you look at, maybe friend B down here, they got a little bit different answers. 4 said country, 10 said pop, 5 said rock, and 1 said rap. So people answered a little bit differently for your friends than from you. So here's what it's going to ask us. It says, and I just copied in this chart again on the next page so that we could see it better. I'm going to erase that. It's kind of annoying. Okay, if there are 840 students in the whole school, estimate the number of students who prefer pop music. All right, so we're going to look at each person's sample rather than at the total to figure this out. So first we're going to take you, and yours had 13 out of 20 people said pop music. We'll set that up as a proportion because it should be proportional to the number of students who like pop music out of the total population. Once we have the proportion set up, we can cross multiply. 20x equals 10,920. Divide by 20 on both sides, and we get 546. So your estimate based on your sample would be about 546 students like pop music. All right, so I'm going to write that here next to you, 546. And then we're going to do the same thing with each friend so that we can get a piece of data for each friend based on their findings. Let's do friend A. They had 8 out of the 20 people say pop music. We set that up as a proportion over the total and do our multiplication. 20x equals 6720. And then divide both sides by 20. Okay, so friend A's estimate based on his sample would have been 336. All right, I'm going to have you go ahead and pause the video, and I want you to calculate the other 3 friends B, C, and D on your own in your notes and come up with the number of students that each of them would have predicted would find pop music, or would say pop music was their favorite. So pause the video and then we'll compare the answers when everyone's done. All right, if we start with friend C, or actually friend B, we hadn't done that. Okay, so B had 10 out of 20, and that's going to be X out of 840. I can see here that this is going to be 50%, so I know that 10 out of 20 is half, so half of 840 is 420. Okay, let's do friend C. They're going to have the same thing, so they have 10, out of 20 will equal X out of 840, and 10 out of 20 is half. So they would also estimate that about 420 of the whole school would want pop music, or say pop music is their favorite. And then lastly, if we did your friend, let's do this in gray, friend D has 9 out of 20 equals X over 840. So 20X equals 7560. Oops, I'm running out of space here. Divide by 20. Their estimate would be 378. All right, so based on our different samples that we polled, right, your friend and you, we get slightly different predictions for what the whole school would come up with. So we're going to work with these little pieces of data on the next slide and make some conclusions from them about what we think about the whole population. All right, so it tells us describe the center and the variation. So remember we said center means median, variation means range. So what we're going to want to do is put these in order from least to greatest. So start by going least to greatest. I'm going to write that here. That helps us we can't find the median or the range without having them in least to greatest order. So these are the same numbers from the last slide. So our lowest number is 336, then 378, then we have 422 times, and finally our largest number is 546. The median of a set of data is the number that is in the middle. So when we set them least to greatest, we cross off the smallest and the largest until we are left with 1. So the median, actually, of this set of data is that middle number. The median is 420, or the center is what this chapter will also call it. You'll see it both ways. The range is going to be the difference between the highest and the lowest number. So the range, or the variation, will take the highest number, 546, and subtract the lowest number, 378, which gives us 168. So our range, or the variation in our data, means that we have values no more than 168 people apart. So it's our estimates vary by no more than 168. And the middle number is 420 out of all of our estimates. All right, let's look at example 2. It says you want to know the mean number of hours. So mean, another word for mean is the average. Number of hours students work at part-time jobs. You survey 10 students at 6 different schools, and this is the data that you get. So school A, school B, each of these is showing your 10 students that you surveyed, and they're telling you how many hours they work per week. Here's what the question asks. Find the variation and total average hours students work each week. So what we're going to need to do with all of this data is find the mean of all the data and then be able to find the variation from there. So let's find the mean of each of these. Remember, to find the average, we add up all the values. So we would do 6 plus 8 plus 6 plus 6 plus 7 plus 4 plus 10 plus 8 plus 7 plus 8 and divide by the number of values there are. And there are 10 values because we surveyed 10 people. All right, so I'm going to move this on to the next page just so that we have a little bit more room. But let's find the mean of each data set, and then we'll use that all together. All right, so let's find the mean of each sample. So first, oops, I didn't mean to do that. First, let's find the mean of set A. We will add all the values together and divide by 10. All right, so all of these added together give us 70 and divide by 10. So our mean is 7. Set A, the mean is 7. Set B, if we add all of these values, 10 plus 4 plus 4 plus 6 plus 8 plus 6 plus 7 plus 12 plus 8 plus 8, we get 73 divided by 10, again, because there were 10 people. And so our mean for set B, 73 divided by 10, is 7.3. All right, set C. 10 plus 9 plus 8 plus 6 plus 5 plus 8 plus 6 plus 6 plus 9 plus 10 is 77 over 10 gives us a mean of 7.7. Letter D, E, and F, I'm not going to do them all out, but D we get 50 divided by 10, so our mean is 5. Letter E, we get 80 divided by 10, so our mean is 8. And letter F, we get 90 divided by 10, so our mean is 9. So here, this is the mean of each set of data that you collected at each school. Now, to find the range of this data, we want to set them up least to greatest. So 5 is our least, 7, 7.3, 7.7, then 8, and 9. So the range, we would take the highest value minus the lowest value, 9 minus 5. The range is 4. So you have found a range, a mean of the samples. If we find the mean of all the samples, I think that's what it asks us to do next, the mean of all the averages, we know that that's going to vary a bit, right? We've gotten all different values, but if we find the mean, that'll give us a really good measure of this data, and we know that it's going to range 4 points give or take, because that's our range of all of our values. To find the mean of all the averages, we would add these values together. 5 plus 7 plus 7.3 plus 7.7 plus 7.8, plus 8 plus 9. And so if we add those all together, we get 44. And divide by 6, because there are 6 different samples that we took. So we get 7.3 repeating. So the mean is about 7.3 of all that data, the average value, the average number of hours that one of these students works, we could assume is about 7.3 repeating, or 7 1/3 hours. All right, a couple things to remember, because this kind of shows up from yesterday, but you'll see it even more. The percent proportion. So in this lesson, they're going to ask you to give percents. So what percent of students, or what percent of the population? Remember, is over of equals percent over 100. So the word that comes before is goes on the top of your fraction. The word that comes after of goes on the bottom of your fraction. The percent goes on the top as a whole number. So 20%, you would just put 20 over 100. Or part over whole. So the part over the whole equals the percent over 100. For example, if they say what percent of 30 is 24, if we say is over of equals percent over 100, our is 24, so we'll put that up here. Our of is 30, that goes on the bottom. And then we're looking for the percent. So this is going to be sort of like our x value here. We're going to solve for the percent. Now that we have this percent proportion set up, now we can do our cross multiply and solve. 30x equals 2400. And then divide by 30. Divide by 30. So we get x equals 800, I believe. No, just 80, not 800. So 80%, so since it asks what percent, 24 is 80% of 30. So this goes back a couple chapters, but it is something that you know. Might just need a little bit of a refresher, so there it is.